back to our review. Okay, even and odd functions was another topic you asked me to go over, so I'm more than happy to do that. Now in class we talked a lot about the graphic representation of an even and odd function. So let's go over that real quick. Okay, a function is even if symmetric about the axes, okay? If it's symmetric about the axes. Classic even function would be our quadratic. Okay, you can see that it is symmetric along the y-axis. And another even function, okay, might look something like this. Okay, you can see that this function is symmetric about your x-axis. Okay, a function is odd if it is symmetric about the origin, right? Remember that? Symmetric about the origin. An example. Okay. Of something that's symmetric about the origin. Okay. Let's move on because I want you to know of another way that you can test to see if functions are even or odd, and that is using an algebraic expression. Okay, a function is even if you can take your function and plug a negative x in for your x values, okay, and be left with the same function that you started with. Now, I will show you an example of this relationship. Okay, but let's talk about a function being odd algebraically if you take a function after you've substituted negative x's in, okay, taking that result and adding it to the function itself, okay, and the sum of this would equal 0. Okay, following along in your review, letter A is our first example. We have f of x is equal to negative 3x squared plus 4. We're going to find f of negative x. Okay, so what that means is everywhere that there is an x in our function, we're going to plug in just a negative x. Okay, let me straighten that for you. So now let's simplify this function now that we've plugged in a negative x. Okay. Well, that's just going to be negative 3 times, now negative x to the second power is just going to leave us with positive x. Then of course that 4 doesn't change. So here's what we're left with. After we plugged a negative x in, we have the exact same function that we started with. Okay, so that's what this means here. We're going to plug in a negative x to our function, and our result is our exact function that we started with is even. Okay. Now let's see what happens when we plug a negative x in to our function letter b. Okay, so we're going to find negative x. Everywhere there's an x in our function, we're going to plug in a negative x. Okay, and then we're going to simplify this. I'm going to write this over here to the side. This negative x to the third power, that's with a negative x result. So I'm going to pull that negative sign out in front of the 2. Okay, there's my result, negative 2x cubed. And then this negative x times negative 4, that's going to give us a plus 4x. Okay, so that's what we were left with after we plugged in a negative x. Now, is this exact same thing as what we started with? No. In fact, it's the opposite, the exact opposite. So if I were to take 2x cubed and add that with negative 2x cubed, that would give me 0. And then if I took a minus 4x and added it with a plus 4x, that would give us 0. So in letter B, this is the case where f of negative x plus f of x equals 0. The results are opposite. Odd function. Okay, so now let's take this function and plug in a negative x. So write this as f of negative x. 2 times negative x cubed minus 3 times negative x squared minus 4 times negative x plus 4. Okay, now I'm going to simplify. We learned in the previous example that negative x to the third power, that's going to leave us with a negative x. And 2 times a negative x leaves us with negative 2x cubed. And then negative x squared gives us positive x. So this would be positive x times negative 3. Leaves us with 3. Negative 4 times negative x leaves us with 4x. And then bring down that positive 4. So here's my end result. So I can see that my first term, negative 2x cubed and positive 2x cubed, are opposites. And I left that x squared off, excuse me. So negative 3x squared and negative 3x squared, these are not opposite, so those wouldn't cancel out. But our first terms would. We have some canceling and we have some terms not canceling. So this, of course, would fall into that category of neither odd or even. Neither. Okay? So there's even and odd functions.